Welcome back to the Python for Beginners series. In this episode, we'll show you how to easily extend the capabilities of Python by using external libraries that can come directly with your own interpreter or be developed by experienced developers. We will talk about several basic libraries, one of which will provide us with functionality for date and time data types. Understanding how to work with libraries is important in order to learn how to create our own objects and libraries in the next episodes, which we will then reuse. Modules are complete and debugged definitions of objects and their methods that are generally reusable in any project. Some modules come directly with the language interpreter, some are available in the official repository and can be installed with the pip command. To work with modules, we will need several Python commands. In order to start using any module, it is first necessary to tell the interpreter to make it available. The import command is used for this. The import command can be written in several possible ways that give us slightly different functionality. The first variant tells the interpreter to load the required package or module. The interpreter performs this action and initializes the object. If we refer to the object in subsequent code, we use its name and the dot convention for calling objects. In some cases, it may seem advantageous to create an alias for the imported object. The module name may be long, or for other reasons it may not be practical to use the full name. Therefore, Python allows you to use an alias that follows the as keyword. Instead of the full name, we will then refer to the object with this alias. The third option for importing objects is the option of selecting only some of its components. Then we use the notation with the from keyword, which allows us to select only those objects that we want to initialize. The last option is a combination of selection and aliasing. We can select only some objects and alias them in case their names might conflict with already initialized objects in memory. We will also need the built-in dir function for our object explorations. The function can list the attribute directory of all objects and modules currently loaded in memory. If we run it without any parameters, the function returns all modules and objects that are loaded into memory. If we call the function with the name of any object that is initialized and therefore loaded in memory, the function returns information about this object. Let's see how it works in practice. First, let's look at the output of the dir function. After starting the kernel, in the default state the function lists all objects that are currently initialized. I note that the objects we see in the Jupyter environment are slightly different from the objects we would see when starting the interpreter from the command line. We see several objects, among which we also find the built-ins module. This is a module that contains built-in functions and objects. We can look at his directory. If we scroll through it, we will find several objects that are familiar to us from previous episodes. But we will try to import the math module, which Python provides for more complex mathematical calculations. The import took place without error. Let's see how it will affect the directory of initialized objects. The module appeared towards the end of the list, which means that we can use it. For example, we can display help for the module or call any function. As you can see, the function name cannot be called directly, but we have to use the qualifier, as we have already explained. We can also import modules using an alias. Very often in various tutorials we will come across an alias for the pandas library. Of course, we can choose the name of the alias according to our own preferences and needs. As in the previous example, we can make sure that the imported ones are included in the directory of initialized objects. We can test how to call help, and we can also call the object immediately, all of course using the alias we chose. In the last example, we can show how it is possible to import only the part of the library that we will use. The import command initializes the sine object. The second part initializes the cosine object using the alias. If we call the dir function, we can see that the objects have been initialized at the top level. For completeness, let's mention one more variant of notation. We can use the import command in combination with the keyword from to import all existing library objects. In that case, we put an asterisk after the import command as a wildcard. The import statement used this way causes all library objects to be initialized at the top level. This means we don't need to use a qualifier when calling them. However, objects initialized in this way can cause name collisions, and it does not contribute to transparency in any way. Thus, such use of the import statement is very rare. In the previous explanation, we came across the DateTime library several times. It is a standard library that allows us to work with data objects that store date and time in Python. Let's show it. We can import the DateTime module in the standard way. An alias is mostly used because the module name is long, and using an alias shortens the qualifier entry considerably. By importing a module, we initialize an abstract class that allows us to use new data objects and their methods. The time delta object handles the representation of a time interval. This means the time period between the start time and the end time. The timezone info and timezone objects are able to store information about time zones. In conjunction with the datetime and time objects, they allow specifying time data, among other things, with regard to daylight saving time. Date objects are able to store and process a date as we know it from a calendar. They contain information about the year, month, and day. On the contrary, they do not contain information about time. Time objects do not contain date information, but only time, which is composed of hour, minute, second, millisecond. DateTime objects are a combination of the two previous ones. These objects keep complete information about the date and time. Let's see what we can do with the DateTime module. I imported the module under the alias DT. For one thing, it's a fairly established practice, but my personal reason is that I'm too lazy to write out the full name. We can create a date object in several ways. We can use the today function to return the current date. But if we look in the help, which I personally always recommend, if we are learning and we are not sure, we will find other ways to create the object. Another option is to pass year, month, and day parameters. The parameters must be of type integer and must make sense to construct valid data. If the date cannot be constructed from the past parameters, the interpreter returns a value error with a description of the error. In these two examples you can see that the date cannot be built because in the first case I entered an invalid month, and in the second case I entered a day that does not exist for the month of February. We can pass parameters both positionally and, in this example, of course also named. Another option is to create an object from ISO format. In that case, we only pass a single parameter, which is of type string and must contain a valid date. We can also perform arithmetic operations with date-type objects, similarly to what we have shown with other data objects. But because datetime objects are specific in the data structure they hold, the arithmetic is a bit more complicated. An attempt to add an integer to a date was aborted with an error because the two data types are incompatible. So how do we achieve this if we want to add a few days to the given date? In that case, we need to use the time delta object. A time delta is a special object that can store an arbitrary time interval. If we subtract the two previously created data objects from each other, we get the interval length in the time delta object. We can easily verify that it is a time delta object with the type function. Let's look at the help again. In addition to the way we just created the object, help says that we can create an interval in the same way we created a date object. We can therefore create an arbitrary interval by entering the appropriate arguments. So let's get back to our problem. How to add several days to an already existing date? We simply create the appropriate interval. Whether it is days or hours, the addition works correctly. Of course, the intervals can be added and subtracted from each other as well. A more complex data object provided by the DateTime module is the DateTime object. Do not confuse the name of the module with the name of the object itself. The object allows you to store complete information about the time, including the date. Since it contains time information, it is also possible to use the time zone object. Let's look at the help again. An object can be created by entering parameters year, month, day. Although this is a complex object for date and time, it is not mandatory to provide time parameters and also an optional time zone parameter. If a parameter is optional, it is recognized in the help by the fact that the parameter is enclosed in square brackets. Just as we used the today method for the date, we can capture the current time with the now method of the DateTime object. As can be seen, the current time was captured with a resolution down to milliseconds. Another possibility to create the object is again from the ISO format. In that case, we pass a single string parameter to the method, which must contain correct information from which a valid date and time can be created. If we talked about time zones, they can also be added to the time data in the object. Working with them is somewhat clumsy. One option is to create a time zone offset. Pacific Standard Time is offset by -8 hours from Coordinated Universal Time. So we create the appropriate interval and pass it to the method in the tzinfo parameter. As you can see, the time zone information has been added to the object. As I said, this kind of work with time zones is rather annoying. Python therefore offers several libraries that make our work easier. I often use the pytz module for my needs. As you can see, adding a time zone is much easier. If you need to list all the time zones provided by the object, they are stored in the common time zones list. And just to repeat the knowledge we got in the previous episodes. What does this command do? There would certainly be plenty of examples of how we can play with DateTime objects. I will list only a few frequently used ones. A while ago we created the Now3 object. It is comprehensive information about date and time, including time zone. This object has its own methods and attributes. We can use the date method to convert it to the date data type. What happens is that we remove the time information and only the part that gives the date is used. We can also convert the object to time. But if we do that, we will also lose information about the time zone, because the time object does not work with it. We can also query the object for the day, month, or year. The month represented by the number 3 corresponds to March. If we call the ISO weekday method, we get a number that corresponds to the order of the day of the week. In our case, the number 1 corresponds to Monday. Two important methods that you will certainly encounter in the future are methods for formatting and parsing date and time data. We can format the object in any format using a mask. In this case, we tell the interpreter that we want to generate a date in the form of day, month, and year, and we want to separate the individual data with dots. The opposite operation of formatting is parsing. Here, on the other hand, we tell the interpreter that we have a string object that contains a date in the format month, day, and year, and the individual data are separated by slashes. As you can see, Python will easily create a DateTime object from this data. So that's all for today's episode. We learned how to import modules and showed the basics of working with date and time. In the next part, we will look under the hood of object programming and learn the basic theory about objects. If you like the Python series for beginners, don't forget to subscribe and I'd appreciate a like too. I look forward to seeing you in the next episode.